So this is from NEET 2016. A charge flowing through a resistance R varies with time t as q is equal to at minus bt square. A and b are positive constants. The total heat produced in resistance R, and these are the options. So the charge, it is varying with time t by the relation q is equal to a t minus bt square. Okay. Now heat is produced due to flow of current in a resistor. So from this charge we can find current I as rate of flow of charge dq by dt. So that is a minus 2bt. Okay. Now the time for which this current flows is can be found by equating it to be equal to 0. So that gives a is equal to 2bt, or t is equal to a by 2b. So this current flows for this time. So the heat produced can be calculated by integrating the expression I square r dt in the limit 0 to t, where what is the value of t? T is a by twice b. Okay. And what is I? I is a minus 2bt. So h equal to 0 to a by twice b. I is a minus 2bt. So a minus 2bt square r dt. Okay. So now this on integration, first let us square this term. So this is h is equal to 0 to a by twice b. This is a square plus 4b square t square minus 4abt r dt. Now if I take this r constant, and then this reduces to h equal to r, this is a square t, this is plus 4b square t square becomes t cube by 3 minus 4ab, t becomes t square by 2, and the limit is from 0 to a by twice b. Okay. Now substituting this limit, we obtain a cube r divided by 6b. Okay, that is option number 4. So this option is the correct answer. So this is how you have to solve this question. So in 2015 we had a question based on the concept of potentiometer. A potentiometer wire of length L and resistance small r connected to in series with a battery of EMF E0 and resistance R1. An unknown EMF E is balanced at a length L of the potentiometer wire. The EMF E will be given by, and these are the options. Okay. So this is the potentiometer wire. Okay. And this is the driving cell connected with internal resistance. It has an internal resistance R1. Driving cell is, this is E0. So this is R1. Okay. Length of the potentiometer wire is L. An unknown EMF E. So this is unknown EMF E. Okay. And it balances at length L. So L is the balancing length. Okay. AB is the potentiometer wire of length capital L. Okay. Now we know that for potentiometer the potential drop is proportional to the balancing length. Okay. And that is, now that means, see, if L, small l is the balancing length, that means potential drop across this part is same as potential drop across this part. Now this is E, so potential drop across this part is also E. So E, it is proportional to L. This is the principle of potentiometer, and this E, it is equal to, proportionality constant is I rho L. Proportionality constant is I rho. Here I is the current flowing through the potentiometer wire, and rho is the resistance per unit length. Okay, rho is resistance per unit length. Resistance per unit length of potentiometer wire. Okay, so E is the EMF of this cell that is asked. Okay, what is I? I is the current flowing through the potentiometer. Okay, as we know, potentiometer does not draw any current from the circuit which is under investigation, so it will draw current from this part. Okay, so now this part, it is in series with this resistance potentiometer, and it is already given the potentiometer resistance is capital R. So the resistance of this part is R, resistance of this cell is internal resistance is R1. So this R1 is in series with this AB part of resistance R. So the total resistance will be R plus R1. Okay, so this is the total resistance. So the current will be this EMF E0 divided by R plus R1. So this is the current. And what is rho? Rho is resistance per unit length. What is the total length? Capital L. What is the total resistance? Small r. So resistance per unit length will be R by capital L into this small l. So this is the EMF. Okay. Now corresponding to the options, as you can see, option 3 matches with this. So option 3 is the correct answer. So in 2015 there was one more question. Two metal wires of identical dimensions are connected in series. Sigma 1 and sigma 2 are the conductivities of the metal wires. The effective conductivity was asked. Okay. So now since they are connected in series, okay, if this is resistance R1, this is resistance R2. So the total resistance R will be equal to R1 plus R2. Okay. Now resistance R, it is given by rho L by A, where rho is the resistivity. In terms of conductivity, this will be L by sigma A. Okay. So if capital R is the effective resistance of these two wires, so it will be 1 by sigma L length, this is L and this is also L. So L plus L, it becomes twice L. So twice L divided by A. Cross sectional area remains same. Okay. So this will be equal to, for this R1 it will be 1 by sigma 1 L by A plus similarly 1 by R2. For R2 it is 1 by sigma 2 L by A. So this L A terms cancels out. So this is 2 by sigma is equal to 1 by sigma 1 plus 1 by sigma 2. Okay. So on simplifying this, it reduces to sigma is equal to 2 times sigma 1 sigma 2 divided by sigma 1 plus sigma 2. Okay. So among the given options, option 2 matches with this. So this is the correct answer.